This narrated PowerPoint on electrical components will have some embedded YouTube videos that are very interesting and will help you understand how the components work. Relays. An electrical device typically incorporated in electromagnet, which is activated by a current or signal in one circuit to open or close another circuit. You see relays in everything. Everything you own in your home most likely has a relay. These are three fairly common relays in the air conditioning and heating system. The one on the left is a fan board. Our units in our lab all have this type of fan board. It has, on this picture, it shows a 3-amp fuse, which protects the board from an overload of power from somewhere else in the system, and the black box, which is the actual relay. The rest of this board is a time delay or extender, so it either keeps the fan on for a longer period of time at the end of the compressor cycle, or it turns it on slowly so it gives time for the heat exchanger to heat up or the coil to cool down before it starts blowing air. The one in the middle is a standard relay for turning on a fan. This can also turn on the fan. You don't need a board, but this does not have the time delay involved in it. The third one is a sequencer. This usually turns on heat strips, and what makes this difference is when it activates with a 24-volt power source, like your thermostat, it sends on the first level, and then after a certain period of time, depending on its design, will turn on the second level of heating.
Hello my viewers, I appreciate the comments on my last video about the relays, and I guess I forgot to add a few extra facts about those relays. So first of all, the actual name, the real live name, generic name, whatever you call it, is a switching relay. Okay, that's the actual real live name for them. And to show you a little bit more about these relays, I've included some things about single pole, single throw, single pole double throw, single pole normally open and single pole normally closed. And as an extra bonus, I'm including double pole double throw. Remember this relay? And here we have the SPST relay, which is the 4-pin relay. SPST means single pole, single throw. And the way this works, you see this is a wiring diagram that I made up. It looks a little bit different from the wiring diagram that is printed on the side of the relay, but it means the same thing. 1 and 3 is your coil, and 2 and 4 is your single pole, normally open. So when it energizes, it closes. And now for the 5-pin relay, which is the SPDT, or single pole double throw relay. We have here again positions 1 and 3 is your coil, and positions 2 and 4 is your normally open position, and 5 and 4 is your normally closed position. If you take note, on this relay there's really only 5 pins. Number 4 pin is where you would connect your power coming in that you want switched. So when this relay energizes, 2 and 4 close and 5 and 4 open. And now for the 6-pin relay, which is the SPNO and SPNC single pole normally open, and single pole normally closed. And I'm going to explain how this is figured. Just as the other two relays I showed you, you would connect your coil voltage to positions 1 and 3. Position 2, like right here, and position 4, which is this pin, is the normally open side of this relay. Positions 5 and 6, right here and here, is where you would connect your normally closed position. So that means when this relay energizes, positions 2 and 4 close, and positions 5 and 6 open. Okay, now just as a review, to show you again the type of relay that I showed to you in another one of my videos, which is the 8-pin. That was the double pole, double throw. Of course, your coil voltage will connect right here. Here's your first pole, which is position 1, as shown here, and your second pole, which is position 4. What makes it a double throw is that when this relay is entered, that it closes the switch between 1 and 3 and 4 and 6, thus making positions 2 and 5 then open. Hello, my
Hey guys, this is Craig Migliaccio with AC Service Tech, and today what we're going over is how does a sequencer work and how do you troubleshoot it. So these can be referred to as heat sequencers or fan sequencers, and this is a 2-switch model right here. We also have a single switch model right here. This video is sponsored by our friends over at Danfoss, and we have a link to their free e-lessons down in the description section below. So here we have 2 sequencers, and this one is a 2-level one. So you have 2 sets of normally open contacts. The one set is between 1 and 3, and the other set is between 4 and 5. And then down here you have these tabs are connected to a pan heater, and inside the pan you have a thermodisc. So what happens is when you apply power to the pan heater, it's going to heat up the pan and the thermodisc is going to flex. And on top of the thermodisc, you have a rod that comes up to 1 and 3 and another rod that comes up to 4 and 5. So that rod is going to normally open the contacts between 5 and 4 and 3 and 1. When the pan gets heated up and the thermodisc flexes, the rod is going to then move down along with the middle of the thermodisc, and it's going to close the contacts between 3 and 1. And then it's going to also close the contacts between 5 and 4. Now that rod is a little offset from each other, so there's 2 rods side by side, and there's going to be these time requirements. So 1 to 3 is going to be a different time requirement than 4 to 5, just because of the position of the 2 rods inside. So up here at the top you see 4 to 5, and then next to it you see H1-20. So what that means is that it's going to take 1 to 20 seconds for these contacts right here to close after powering the sequencer. After you disconnect the power down here, it's going to take 40 to 120 seconds for these contacts to open back up again. So just say you started at no power here and you're going to go ahead and power this. The second level of contacts is going to take 30 to 90 seconds for those contacts to close. And then when you take the power off the pan heater, it's going to only take 1 to 30 seconds for these contacts to open back up again. So this works just the same way. It just has 1 set of contacts with 1 set of time requirements. So this transformer is not powered. Even though it's connected, it's not powered. I just want to go ahead and show you what this little plate looks like and the thermodisc. So you have your 24 volts coming over to this piece of brass, and it's touching this right here, which is your heater for your pan. And then this little thermo disc is actually pointed upwards in the middle right here and just sits right in the pan. As it heats up, it's going to then make a noise. It's going to go boom, and it's going to tilt this part inwards. Okay, so I can press it in by my hand just like that. So that's what makes up the bottom part, and then this thermo disc pushes up on the rods. So you see these two rods right here? So the short rod goes up to the first set of contacts, and the longer rod goes up to the second part of contacts. So in this case right here, this is the first set of contacts. We'll just take the short rod, and the short rod is going to, normally it's going to be pushing up on this contact just like this, and that's how it's going to be when it's not powered with 24 volts. After you power it and you wait the period of time, what it's going to do is it's going to allow that contact to then close the electrical circuit. So this is not powered, and this is powered after the time requirement. The second rod goes right in the middle. So it goes right through, and then it gets up to the top set of contacts. So you see you have that second rod in now, and it's normally going to be like this. They're normally both going to be pushed inwards. And so you have the contacts on the top. They're open until you power the sequencer and then wait for the allotted amount of time. Then it's going to close the contacts. So you see how it can open the contacts or close the contacts. So I want you to see this right here. This is a plate that covered over top of this. You can see the burn marks right on there. And this contact right here is actually pitted and burnt. So it's no longer making a good connection from one side to the other. Now we're going to power the pane heater, and we're going to see how long it takes for the thermo disc to go ahead and pop. Now we'll disconnect our 24 volts. So in reference to troubleshooting, you can check to make sure that you don't have OL from one point to the other point for where you're going to connect your 24 volts at. Basically, all you're doing is you're checking the resistance value of this little pane heater, and you're checking it from one side to the other. So maybe one of these little brass parts right here melted or something like that, and that's why you read OL. If that's the case, the sequencer is no good. In reference to troubleshooting the normally open sets of contacts, such as from 4 to 5 and 1 to 3, you're just going to go ahead and hook your multimeter up across those contacts. Make sure you disconnect your wires off of that first with the power off, and then you're just going to check this with resistance. So right now you see that we're reading OL, which means over limit or open line, and that means that those contacts are not connected. So we're just going to go ahead and time it to see how long it takes to close those contacts when we apply 24 volts to it. So over here at the top you see 4 to 5. It takes 1 to 20 seconds for those contacts to close, and then it takes 40 seconds to 120 seconds for those set of contacts to go ahead and open back up again. So here we go. So what's happening now is you just have that little pane heater is heating up the thermo disc. So it really shouldn't take long, and there you go. So we're reading 0 ohms of resistance across the contacts. And now let's go ahead and see how long it takes for the contacts to open back up again. We've disconnected the power now. There you go. That was on the lower end of the 40 to 120 seconds. So that was probably right around 35 seconds or so. But you see that we are no longer connected on those contacts between 4 and 5. So right now the sequencer is not powered. We're going to go ahead and power it again with 24 volts. We're going to read 0.0 ohms of resistance after the allotted time requirement, and this one is 1 to 20 seconds. But then after that I'm going to switch the probes down to the lower level, and that one is supposed to close between 30 and 90 seconds. So you're going to notice that they're not going to both close at the same time. You have to follow these time requirements, and that's because the rod is slightly offset from the other one when it's sitting on top of the bimetal disc. Okay, so now it clicked. We're going to go ahead and move these down to the lower level. And you see that we're reading OL. So now we're reading 0.0 ohms of resistance. I'm going to go ahead and disconnect the power, and on this lower level right here between 1 and 3, it should open the electrical circuit up a lot faster than between 4 and 5 at the top. So here we go. Now we're going to go ahead and switch these because these ones are likely still going to be connected up top. So that's how you troubleshoot these. You just go ahead and apply voltage, and then make sure that when these are closed, you're reading 0.0 ohms of resistance and it's meeting the time requirement. As well, with the power off, the 24 volts off of the pan heater, you can check the resistance value of that down there. Make sure that you're not reading OL. If you're looking for the multimeter or the other tools I use out in the field, I have them all linked down in the description section below. If you want to help support this HVACR training channel, click here. If you want to subscribe, click here. And if you want to see another HVACR training video, click right here. Hope you enjoyed yourself, and we'll see you next time at AEC Service Tech channel.